JEE Advanced 2025, Paper 2, Physics, Question 8. Let us first visualize the system. We have a Carnot engine connected to a heat pump. The Carnot engine operates between a hot reservoir at 1000 Kelvin and a cold reservoir. It extracts 150 joules of heat per cycle. The work output from this engine drives a heat pump with a coefficient of performance of 10, whose hot reservoir is at 300 Kelvin. Let me keep this diagram as reference while we solve the problem. Here is the question. The efficiency of a Carnot engine operating with a hot reservoir at 1000 Kelvin is 0.4. It extracts 150 joules of heat per cycle from the hot reservoir. The work extracted is fully used to run a heat pump with coefficient of performance 10. The hot reservoir of the heat pump is at 300 Kelvin. We need to identify which statements are correct. The key concepts needed here are Carnot engine efficiency and heat pump coefficient of performance. For a Carnot engine, efficiency eta equals 1 minus Tc over Th and also equals W over Qh. For a heat pump, the coefficient of performance equals Qh pump divided by W, which also equals Th prime divided by Th prime minus Tc prime. And by energy conservation, Qh pump equals Qc pump plus W. Let us solve step by step. First, finding the work extracted from the Carnot engine. Efficiency eta equals W over Qh. So W equals eta times Qh, which is 0.4 times 150, giving us W equals 60 joules. Therefore, option A is correct. Next, finding the cold reservoir temperature of the Carnot engine. We use eta equals 1 minus Tc over Th, substituting 0.4 equals 1 minus Tc over 1000. So Tc over 1000 equals 0.6, giving Tc equals 600 Kelvin. Option B is correct. Now for the heat pump. The coefficient of performance of a heat pump is defined as Qh pump divided by W. With COP equals 10 and W equals 60 joules, we get Qh pump equals COP times W, which is 10 times 60, giving Qh pump equals 600 joules. Option D claims Qh pump is 540 joules, which is incorrect. Finally, finding the cold reservoir temperature of the heat pump. Using the COP formula for a heat pump, COP equals Th prime over Th prime minus Tc prime. Substituting, 10 equals 300 over 300 minus Tc prime. So 300 minus Tc prime equals 30, which gives Tc prime equals 270 Kelvin. Option C is correct. The correct answers are options A, B, and C. Work from the Carnot engine is 60 joules, cold reservoir of the engine is 600 Kelvin, and cold reservoir of the heat pump is 270 Kelvin. Option D is incorrect because the heat supplied to the hot reservoir of the pump is 600 joules, not 540 joules. Here are some important tips for thermodynamics problems in JEE Advanced. First, always distinguish between heat engine and heat pump COP definitions. For a heat pump, COP equals Qh over W, not Qc over W, that is the refrigerator COP. Second, use both the efficiency formula and the temperature formula to cross-verify answers. Third, in combined engine pump problems, the work output of one device becomes the work input of the other. Track energy flows carefully. Fourth, remember that COP of a heat pump can be greater than 1, which often confuses students. If you found this helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next one.